Hi everybody, welcome to another video in Pre-Calculus section 5.2, Right Triangle Trigonometry. In the next few chapters we study about trigonometry. However, we approach trigonometry from different aspects than the regular trigonometry class. So this is more like a review. Right, so trigonometric function. First, of course, how do we define those functions? So first we have a triangle, a right triangle, and let this angle be theta. Now with respect to this angle, we have the opposite to this angle, adjacent to this angle, and hypotenuse is the longest side, which is opposite of the right angle. Right, so since we have three sides, and we just take two of them, divide each other, so there will be 6 ratio in total. If we just pick two of this, divide by each other, we have 6 of them. And the way we define this is the side is opposite over hypotenuse. And cosine is adjacent over hypotenuse. Tangent, opposite over adjacent. Cotangent will be reciprocal of tangent, so will be adjacent over opposite. And secant is reciprocal of cosine, will be hypotenuse. Over adjacent. And cosecant, hypotenuse. Over opposite. So we have tangent and cotangent are reciprocal of each other. Secant and cosecant are reciprocal of each other, and sine cosecant reciprocal of each other. All right. Now in terms of the triangle ABC, we have A is adjacent, B is opposite, and C. So we can just, based on that triangle, we have sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. And then we just tangent and cotangent, we're just going to flip cosine and secant reciprocal, and sine cosecant reciprocal of each other. Right. So pretty much all we need to know is the 3 ratio, and then the other 3 ratio are reciprocal of each other. So there's, if you look online, there's a bunch of different way to memorize this, and of course I'm going to write a few of them here. So sine, cosine, and tangent. So there's an acronym. Let's see. So the old angel sitting on heaven carries a harp. So tangent is opposite over adjacent, sine is opposite over hypotenuse, and cosine adjacent over hypotenuse. Of course, there are a lot more that you can find online easily. Of course, I know one more. So some old hippie got another hippie. Right, so sine opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent is opposite over adjacent. Usually we just need 3 of them, and the other 3 are reciprocal of each other. So these 2 are reciprocal of each other, meaning we just flip. These 2 are reciprocal of each other, and sine and cosecant are reciprocal of each other. Right, now that's simple enough. So in this book, the way they approach trigonometry, they use the right triangle trigonometry. So we just define trig function based on the right triangle. So this, because of the right triangle, this angle is an acute angle. So the trigonometry function here defined only for an acute angle, meaning less than 90 degrees, from 0 to 90 degrees. Right. Now let's see, we have this right triangle. And now find the values for 6 trigonometric functions of the angle theta here. Right, first we have 13. This is hypotenuse. 5 is adjacent to the angle, and this is opposite to the angle. We know hypotenuse, we know adjacent, we do not know opposite. So first we need to solve for it first. So let's say we don't know this. Let's say the length is x. In the right triangle we have Pythagorean theorem, 5 square plus x square equal to 13 square. So we can solve for x square easily. 13 square minus 5 square. 13 square is 169 minus 5 square 25. So we have 144. And take square root on both sides. We have plus or minus 12, 144, which is plus or minus 12. However, this is the way we define trigonometry in this section. Is only for the right triangle. In right triangle, the measurement of them just positive. We don't have a negative measurement in a triangle, right? So we choose positive. So that's going to be 12. Yeah, so opposite is going to be 12. Right. After that, it will be easy. Just write 6 trigonometric function. Sine of theta is opposite. Just want to write opposite over hypotenuse. Opposite is 12. Hypotenuse is 13. Right. So that is sine. Opposite to sine is cosecant. We're just going to do the reciprocal, so it will be 13 over 12. Right, so that is sine. Cosine is adjacent over hypotenuse. Adjacent to that angle is 5. Hypotenuse is 13. And reciprocal of cosine is secant. And next, we have tangent. Is opposite over adjacent. Opposite over adjacent. And cotangent is reciprocal of that. That's simple enough. I will do the same thing for this triangle. This will be the right angle, and this is the angle theta. So with respect to this angle theta, opposite is 3, and adjacent is 4 with respect to that angle. And hypotenuse we don't know. But we have Pythagorean theorem, 3 square plus 4 square is equal to x square. So once again, x squared is 25, which will be x is plus or minus square root of 25. But once again, this is the measurement in a triangle. It cannot have negative measurement, so it's just going to be 5. Right? So that's going to be 5. And then we just write the 6 ratio sine opposite over hypotenuse will be 3 over hypotenuse 5, and reciprocal of sine is cosecant. Cosine is adjacent over hypotenuse. Before adjacent over hypotenuse 5, and then secant is reciprocal of that. And then tangent opposite over adjacent. Opposite 3, adjacent 4, and then cotangent is reciprocal of that. Right, so that's what we have. So next we have some fundamental trigonometric identities. Of course, if you took my trigonometry class and you already see this, so I found this trigon line. Right, so what we have is the ratio, of course, cosecant reciprocal of sine, secant reciprocal of cosine, cotangent reciprocal of tangent. We've seen that, we used that before. Now, the way we construct the hexagon is this. We have the hexagon, tangent, sine, and cotangent. And then opposite to tangent is cotangent. Opposite to sine is cosecant, and opposite to cosine is secant. I mean, opposite from the hexagon, it is not opposite in terms of mathematics, like negative. So opposite from the hexagon, from the center. Right. And then we have tangent is sine over cosine, and cotangent is cosine over sine. Of course, it's easy to verify. We have sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Divide fraction is multiply reciprocal. Opposite over hypotenuse. And then we cancel that. We have opposite over adjacent, which is tangent. So it's easy to show. But bottom line is, if we have this hexagon, there will be 3 ratio. For example, if we put tangent on the upright on the top, we will have 3 ratio. That is sine over cosine, 1 over cotangent, and secant over cosecant. So we can say tangent will equal to 3 ratio sine over cosine, 1 over cotangent, and secant over cosecant. Now we can switch any function on the top. For example, if we have sine on the top, that will be equivalent to 3 ratio here, cosine over cotangent, 1 over cosecant, and tangent over secant. So whatever function on the top, we have 3 ratio. Right. Then you can also take a function will equal to a product of 2 function adjacent to it. So sine is equal to tangent times cosine. Secant is cosecant times tangent, and cotangent equal to cosecant times cosine. So any function is the product of 2 adjacent functions, which we don't have here. And finally, Pythagorean identities. We have that direction. So cosine square plus sine square equal to 1. 1 square plus tangent square equal to secant square. And cotangent square plus 1 square equal to cosecant square. Of course, 1 square is equal to 1, so we just need to write 1. Right, so that gives us the Pythagorean identity. Right. Right. Now, let's go to this example. Given that theta equal to square root of 10 over 10, sine of theta equals square root of 10 over 10, and cosine is 3 square root of 10 over 10, find the order for trigonometric function. Right, so we just write out. What do we have? Sine square root of 10 over 10. By the way, in my math lab, when you type the answer, usually we can type like this, where we have no square root at the denominator. But in terms of math, it doesn't matter. We can write this as square root of 10, and 10 will be. So what I do is I can just multiply square root of 10 top and bottom. So when we do that, we have square root of 10 times square root of 10 is 10. At the bottom 10 square root of 10. So in that case we can cancel out the 1. Cancel out the 10. So sine, we can write this also as 1 over square root of 10. Yeah. But technically, we prefer not to write the square root at the bottom, so that's why we can write like this as well. However, when we write like this, the cosecant is easy to find, because cosecant is the reciprocal of sine. So we're just going to flip. That gives us square root of 10 over 1, or just square root of 10. Right, cosine. Cosine 3 square root of 10 over 10. Once again, if we want to, we can just multiply square root of 10 on the top and square root of 10 at the bottom. Square root of 10 times square root of 10, so we have 3 times 10, and 10 times square root of 10. That cancels out. So we have 3 over square root of 10, and that gives us reciprocal of cosine is secant, which is square root of 10 over 3. We're just going to flip this. All right. Then to determine the orders, it's easy. We can use a trigonometric function here. We need tangent, right? Because we have sine, cosine already. So we use tangent is equal to sine over cosine. Sine is, we use this square root of 10 over 10 over cosine 3 square root of 10 over 10. Divide fraction is multiply reciprocal. and cancel out square root of 10, cancel out the 10. We just have 1 over 3. So with that, cotangent is reciprocal of that. It's going to be 3 over 1 or 3. Right, so very straightforward just from definition. Now, more examples. So I think it would be handy if we have a hexagon. So just draw a hexagon. Just draw the diagonal too. We have 1 in the middle. And then tangent, then sine and cosine. And then opposite to sine will be cosecant. Opposite to cosine, secant. Opposite to tangent is cotangent. Then we have the hexagon, because we still have. So when we have sine over cosine, so we just put the position where sine over cosine, we have that ratio, sine over cosine, and since tangent on the top, so that equal to tangent. So this equal to sine over cosine is tangent, and subtract itself is equal to 0. Right. Next we have the ratio of 1 over cosecant. So we rotate this where we have the 1 over cosecant, and 1 over cosecant is sine. Right. So by the way, of course, I don't emphasize enough. When we write, let's say, a cosine of theta, we mean cosine of theta square. We do not mean that is completely different things. In that case, we should just put the parentheses here. Right, so the square here meaning the square of the trig function when we evaluate the trig function first. So, because here we have cosine square. Now, 1 over cosecant. 1 over cosecant. Of course, 1 over cosecant is sine, and since we have a square, we also have the square. Cosine square plus sine square is 1. So yeah, just like that. Next, given that sine is equal to 1/2, theta is an acute angle, find the exact trigonometric function for the other 5 trigonometric functions. So in this case, let's draw a triangle. We know that is trigonometry of an acute angle, so we can draw a right triangle here. So we have sine is equal to 1/2, and by definition of trigonometry of an acute angle, sine is equal to opposite over hypotenuse. So in this triangle we can say the opposite is equal to 1 and the hypotenuse is equal to 2. And then we just need to solve for the adjacent. Right, so we have 1 square plus the adjacent square we equal to 2 square, right? Yeah, Pythagorean identity. I should say Pythagorean theorem. So adjacent square is equal to 2 square minus 1 square, so it will be 3. So adjacent will be plus or minus square root of 3, because just in the right triangle we can just use positive. So it will be square root of 3. Right? So we have adjacent is square root of 3. And with that we can find all the other ratio. Sine cosecant is reciprocal of that will be 2 over 1. And then cosine will be adjacent over hypotenuse. Adjacent over hypotenuse. And reciprocal of cosine is secant. Yeah, we just write like that. Of course, if we want to rationalize the denominator, just multiply square root of 3 top and bottom, so that we will have 3 at the bottom as opposed to a square root. Next, tangent. Tangent is opposite over adjacent. Opposite is 1. Adjacent is square root of 3. Again, if we do not want square root at the denominator, multiply top and bottom by the same square root. So we have 3 at the bottom instead. So tangent, reciprocal of tangent is cotangent. So we're going to flip the square root of 3 over 1, or just square root of 3. Right. So that's what we have. Next, given that tangent is 2 over 3 and theta is an acute angle, find the exact values of the remaining 5 trigonometric function of theta. So once again, we wrote a right triangle. It doesn't have to be exactly 2 over 3 ratio. We just draw a generic triangle. Right, so what we have is tangent. Tangent is opposite over adjacent. And in this case we have 2 over 3. So in this right triangle we have opposite is equal to 2 and adjacent equal to 3, and then we'll find the hypotenuse. So Pythagorean theorem, 2 square plus 3 square equal to hypotenuse square. So we can get the hypotenuse equal to 2 square is 4, 3 square is 9. It's 4 and 9, that's 13. And we take the square root on both sides, and once again in a triangle we can only take the positive values. So we say hypotenuse is equal to square root of 13. Right. Square root of 13. Right. Then we can find this, the other trigonometric function. Tangent, reciprocal of tangent is cotangent. Cotangent is reciprocal, so we're just going to flip it 3/2. Sine, opposite over hypotenuse. Opposite is 2 over hypotenuse is square root of 13. If we don't like the square root at the bottom, we can multiply square root of 13 top and bottom, so that we have 13 at the bottom, then 2 square root of 13. So sine, we have cosine, reciprocal of sine is cosecant. I use this instead. I just have square root of 13 over 2. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So we multiply square root of 13 top and bottom. That gives us 3 square root of 13 over 13. And cosine, reciprocal cosine is secant. I'm just going to take this ratio, and that's why we have. Right, so very basic. We just use the definition of trigonometric function. Right, now complementary angle theorem. So let's say we have a right triangle. It's convention. Opposite to angle B is the sine B. Opposite to angle A is the sine A. Now, of course, C is hypotenuse, is opposite to the right angle. Right, now, in this triangle, let's say this sine is adjacent to angle B, but it is also opposite to angle A. So we have 2 different angles. Adjacent of this one is the opposite of the other one. Because of that, we can say sine of B is equal to cosine of A, and cosine of B equal to sine of A, tangent and cotangent, and secant and cosecant. Right. So what we see here is, think about, let's just say this slowly: sine, cosine, tangent, cotangent, secant, cosecant. Right. So that's what we call this is the Cofunction Theorem, or the function, and we say cofunction of complementary angles are equal. By complementary, meaning that if they add up to 90 degrees, complementary meaning the sum is equal to 90 degrees, or in radian, we can say pi over 2 radian. Right. So we can write it right. In this, we can just say sine of an angle is equal to cosine of the complementary angle, meaning I should say just 90 degrees minus A. So we go from a function to a co-function. We subtract from 90 degrees. an angle. Of course, we can also say pi over 2 if we use radians. We will not have any section dedicated to radian here in this book, but so we just say pi over 2, 90 degrees, 180 degrees is a pi radian. Right. A pi is equal to pi radian is 180 degrees. And then let's say if we have pi over 6, then what's that equivalent to degrees? Well, that is easy. If we want this in degree, we're going to take this ratio. If we want degree, we put degrees on the top and the pi at the bottom, so that this pi and that pi cancel out. 180 divided by 6, that is 30 degrees. Yeah. So if we want to go from the radian to degrees, multiply by 180 divided by pi. If we want to, let's say 75 degrees, and we want to convert to radian, we also multiply by a ratio. Now we do not want degrees anymore, so I will put 180 degree at the bottom, so that the degree and the degree will cancel out, and put pi on the top. So pi and 180, put 1 on the top, 1 at the bottom. If we want degree, put degree on top. If we don't want degree, put degree at the bottom. That will cancel out. And 75 divided by 180. Convert to fraction. 5 over 12. Don't forget there's a pi here. Right, so that is the degrees and radian. Right, so sine and cosine. If we want to go from cosine, we go back to sine. Same thing. Because sine and cosine are co-function of each other. If we go from cosine to sine, subtract from 90. Or we can have from pi over 2. Yeah. Of course, I can write that for all 6 trigonometry function, but we'll need to do that. Now, let's use that theorem to write the complementary angle theorem, or we could say the co-function theorem. So we want to go from sine. Co-function of sine is cosine, and since we go from a function to a co-function, we have to subtract from 90 degrees. That is cosine of 11 degrees. Tangent, co-function of tangent is cotangent. And since we go from a tangent to cotangent, we have to subtract from 90 degrees, but this is in radian, so we subtract from pi over 2. So usually when we do this, we just ignore the pi. We just say 1/2 minus 1/3, and we convert to fraction 1/6, and at the end we just stick a pi to it. That is the cotangent of pi over 6. Right. Now try to simplify this. Secant of 11 and cosecant of 79. By the way, secant and cosecant are co-function of each other. So if we want to keep one of them and the other one we convert to the co-function, that means we have to subtract from 90 degrees. So that gives us secant of 11 degree minus secant of 11 degrees. That will be 0. Now sine over cosine. Sine, cosine are co-function of each other. So if we just want to keep one of them, and we convert the other, from cosine to the co-function of cosine, which is sine, we have to subtract from 90 degrees. So have sine of 37 degrees and sine, and that also 37. So that equal to 1. Now, next we have the interesting problem. Tangent of 10 degrees times tangent 20, tangent 30, tangent 40, 50, 60, 70, and 80 degrees. So what can we do here? By the way, notice that 10 and 80 are complement to each other. 10, 20, 70, 30, 60, 40, 50. They add up to 90 degrees. So we use that. Let's keep half of it and convert the other half. So keep this half. Right. The other half, I will use the Cofunction Theorem. Tangent I will convert to cotangent. Instead of 50, we will have 90 degrees minus 50. And then cotangent of 90 degrees minus 60. And then cotangent of 90 degree minus 70, so that will be 20. Of course, I'm running out of space, and besides we don't need to write out. And tangent of 80 is cotangent of 10 degrees. Right, let's just rewrite this. Tangent of 10, tangent of 20, tangent of 30, tangent of 40. We skip. Now we have cotangent 40, cotangent of 30, cotangent of 20, and cotangent of 10. So what we just use is the Cofunction Theorem. Now, the tangent and cotangent, not only they are co-function of each other, tangent and cotangent are reciprocal of each other as well. So by that we mean cotangent of 40 tangent of 40 cotangent of 40 cotangent 1 over tangent. So we can write this as 1 over tangent. And that will cancel out nicely. Cotangent 1 over tangent 1 over tangent 1 over, I don't need the page number, tangent of 10. And that cancels out nicely. Cancel everything. We don't have anything left. We just have 1. Right. This is a nice problem. We take advantage of tangent and cotangent are reciprocal of each other, and tangent and cotangent also co-function of each other. And so that's what we can apply to that problem. And with this, I stop section 5.2 here, As always, thank you for watching and see you in another video in pre-calculus.